Hello, everyone, and welcome to today's panel discussion. On behalf of American Petroleum Professionals of Iranian Heritage, APPIH, it's our great honor to start another panel discussion. Let's introduce today's moderator. It's our great honor that today we have Dr. Khoshghadam. He has significant experience in reserve estimation, numerical modeling, and data analysis. Currently, he is working for New Dawn Energy Company. I would like to thank Dr. Khoshghadam and the panelists for accepting our invitation. And without further delay, I'm transferring microphone to Dr. Khoshghadam for starting the panel. Thank you.
Oh, okay. Thank you, Hamid. Thank you. Much appreciated. So hello, everybody. I would like to thank APPIH for hosting this event in the past 18 months. Since the pandemic started, APPIH has done a great job in hosting several webinars and virtual events. Hope you will enjoy this panel as well. Today, we are going to talk about a new book in machine learning and its application in oil and gas. The book title is Machine Learning Guide for Oil and Gas Using Python, a step-by-step breakdown with data, algorithm, codes, and applications. The two authors of the book are both have engineering background in oil and gas, and they both are experts in data science and data analytics. Our first guest is Alireza Haqiqat. He's a senior technical advisor for engineering solutions at IHS Markit. And our second guest is Belyadi. He's a senior data engineer and scientist at Vine Oil and Gas. I would like to welcome both guests and ask them to tell us a little bit about themselves, their background, what they have done. I would like to start with Alireza.
Hello and good evening, ladies and gentlemen. I'm Alireza Haqiqat, Senior Technical Advisor and Instructor at IHS Markit. What I do, I support some engineering products for different type of reservoir engineering evaluations like rate transient analysis, numerical modeling, well testing, nodal analysis, and data analytics applications in oil and gas. I joined IHS in August 2019, and prior to that, I was a senior reservoir engineer at Eclipse Resources. I also was adjunct faculty at Penn State for 5 years, teaching a course per semester. I got my PhD at West Virginia University under supervision of Dr. Shahab Mohaggeg, one of the pioneers in oil and gas applications for machine learning. And I did several research. I wrote some book chapters, papers in applications of machine learning in oil and gas industry. And I practiced some of these applications in day-to-day job for engineering problems.
Thank you very much. Just let me ask a question. So what is your day-to-day jobs look like in terms of using the data science applications or data analytics?
Sure, predicting the performance of the well, calculating the EUR, predicting the EUR, optimizing the well performance, these were some of the day-to-day jobs that I used to do with the help of machine learning to do some asset evaluation, field development, and, optimizing some development plan and drilling.
Oh, okay. Thank you. Glad to have you here. How about you, Haas? Would you tell us a little bit about yourself, your background?
Sure. Yeah, thank you. Thank you for having us, and appreciate everybody who signed in today. So yeah, so first off, I started my career, a bit about like 11 years ago. I was in the completion side. So I was primarily on the frac side. I started as a completions engineer for the first couple years. I was hands-on in the field for a couple years. And then after that, I wanted to be in the office and do more engineering work. So I switched from completions engineering in the field to be a reservoir engineer in the office. So I've done reservoir and production for 3-4 years after that. And in the past 5 years, I've been involved in the application of machine learning in the oil and gas industry. And basically, like currently my role is I'm a data engineer, data scientist. I'm responsible for pretty much bringing all the data in one central place and also making it available to everybody. And at the same time, finding hidden patterns in the data that you cannot really see without getting deep into the data. And that includes drilling, completions, production, reservoir, geology. There are different applications of machine learning in all those fields, and I guess one of the beauty that one of the things that I like about my job right now is that I'm involved in different applications and not just one area, so which makes it kind of exciting because it kind of like spans from drilling all the way to production. And also, in addition, I also taught at different like universities in the past, WVU, Marietta College, and San Francisco University. Like I've held short courses also across different parts of the planet, and it's been a fun experience so far.
Oh, great. Just really short questions to for our audience to have a better understanding of your background. How did you guys first exposed to the whole data field? Like, was it through your school or your work? How did you first become interested in the whole data science?
So I can start first. So as I mentioned, I had the opportunity to work under supervision of Dr. Shahab Mohaghegh, who is a pioneer of applications of machine learning and artificial intelligence in oil and gas industry. So throughout my 4 years of PhD, I was exposed to many different applications of machine learning for a wide variety of different disciplines: reservoir engineering, reservoir simulation, production engineering. So that really helped me to get a good understanding. And then when I had a good foundation of data science, I try to apply it in my day-to-day job.
Yeah, and as for me, it was primarily through my job, right? So when we first started the unconventionals, they were like, we were like testing and doing exploration wells, right? We're doing, like in the like I started my career in the Marcellus. We're doing exploration wells, and it wasn't. We didn't have many data points, many sample points, to use machine learning back then, right? And as we got more data and more data, and we had a central place to store all this data, that's when I started looking into, well, what can we do with all this data? There's so much data coming in now, Before it used to be like, okay, we have, 10 wells here, 20 wells here, But as you, like over time, as you drill more and more wells, analyzing these wells become very subjective and become very biased, right? You can use different types of like analyses to, okay, I'm going to compare this pad with this pad. But at some point, you have to look at the field as a whole to understand the entire pattern within each area of interest, And that's when I started getting very interested in, well, what can we do to actually use machine learning and train a model to be able to extract the hidden patterns that we're not able to see, So that's when I started doing it, and it was through my job. I started this about 5 years ago, and that's when I really dug deep into it and found a lot of potential in it, in addition to just like the basic fundamentals that you can do with machine learning.
Interesting. So why did you guys write this book?
Yeah, I can take that question. So, so when we first started, right? I would have loved, and I'm being very honest right now. I would have loved to have something tangible where I could follow step by step. Here's how I can apply and solve this problem with this algorithm, right? Here's like how I can solve this problem. So when we first started, about 3 years ago, like writing this book, there were books in this field. There are a lot of different machine learning books. There's no question about that. As a matter of fact, I encourage everyone to read all those books, but there was no book that taught you how to apply machine learning step by step using Python, for example. You know, there was no such a book out there. You know, so we said, well, why don't we introduce this book and first off, break down these concepts. There were a lot of buzzwords that were being used. Oh, AI, machine learning, deep learning, and all these buzzwords that were being thrown around, you know, without people truly understand what those buzzwords meant, right? So we're like, okay, what we want to do, we want to break down the concept from the beginning, step by step, and also show the codes to the world and show how easy it is to do it. You don't have to, like, for example, you know, spend hundreds of thousands of dollars developing a model, because a lot of these companies use the same exact thing. They use Python, for example, to develop these models. So we wanted to, you know, have a step-by-step guide for students, for people that were in the industry, that didn't have any background in this subject matter, to be able to follow step by step how you can, you know, apply different machine learning algorithms within Python and also use the codes as well. It wasn't just like, you know, just here's the neural network, here's a support vector machine, here's a random forest. Well, how do you apply it and how do you go through the code step by step? So once you're done, you know, going through these chapters in this book, you can at least take your own data set with your own company or your own university or organization and be able to at least apply the code and follow it step by step and be able to find pattern, you know, in this data. So we wanted to focus on breaking it down, making it like in simple terms, and be also able to provide a valuable resource for everybody to use these codes and kind of apply to their own like day-to-day data sets.
Oh, okay. So do they need to have any background in Python or any of the programming language?
No, we actually literally start with, I'm not even, you know, making this up, like 2 + 2. How do you do 2 + 2 in Python? Like with that, like the first chapter is how you download. Where do you download Python or the Anaconda, which has all the libraries, you know, within that, and then start with the basic fundamentals of just basic algebra, and then build on top of it. Now, by chapter 9, it's going to be much more complicated. Okay, we're going to start with the basic fundamentals, the basic concepts, you know, just the if statements, the for loops, and all that kind of stuff in Python, right? And then as you go through each chapter, you know, it's going to get harder and harder and harder. Once you get to Dr. Hayigat's chapter, then you're going to be like, okay, this is this is getting a little bit difficult now, you know. But no, we honestly try to break it down as much as possible, so you don't have to have any background in data science or in coding or any of that stuff. You know, that was the whole intent of this book, to break it down, and also we explain everything. You know, we go through here's the code, or I'm sorry, here's the algorithm.
Yes.
Here's the mathematics behind the algorithm. You know, we have a lot of references throughout the whole book, you know. And also once the mathematics is clear, you know, then we go into here's how you apply it in Python. And then we have data sets we have the entire data set, the entire code, the Jupyter Notebook files. These have all been placed on Elsevier's companion site. Okay, they have a companion site. It's an online link. You click on chapter 1. It has the codes and it has, you know, the data and everything else that you need that we use throughout the book. You know, so you can follow step by step as you go throughout the book. You can, like a lot of books, you know, just have the code, but it doesn't have, you know, like here's how you can follow step by step. But we actually try to do that and have a step by step guide that you can follow.
Okay, thank you. Well, let me ask Alireza. So, I mean, Hassel explain it, you know, some of the differences between your book and, you know, other machine learning books in the market. But so I wanted to ask you, what's the difference of your book in your own point of view comparing to the other books in the market?
Thank you. There are many books in the market that talk about machine learning. And few of them focus on machine learning applications with Python. So if you search into Amazon or Google, for sure you will find tens of books that focuses on machine learning using Python. But for all of these books, in order to really learn machine learning, you need to practice. You need to practice with a data set, with a database. And there are many examples in those books, and all of those examples are great. For example, there is an example for credit card fraud detection for binary classification, or house pricing in Boston, or iris database that talks about flowers, or wine quality. All of these examples are great, but what we really wanted to do, we really wanted to customize this book for the professionals in the oil and gas industry. So instead of those examples that I mentioned, we searched through the oil and gas literature, and we found the actual practices of machine learning in the oil and gas industry examples. And we try to present these examples to all the audiences. So when we want to talk about binary, for example, binary classification, we don't talk about credit card fraud detection. We showed you sand production from a well. Or then, for example, we want to talk about, multi-class classification. We talk about, facies classification based on some geological data. So the examples that we have, the data sets that we provide for our audience are specifically customized for oil and gas professionals. So the terms that you hear is related to, very, very common terms for oil and gas people: pressure, temperature, EUR, production, porosity, decline. These are the things that people used to hear in oil and gas industry. So we tried to provide these examples. So when you want to learn these topics, the examples make sense for you. So the main difference between this book and other books in the market is the examples and the practices are mainly customized for the people in oil and gas industry.
And I am guessing that all of these examples, the data sets and codes are available in the book, or like the host mentioned, the Elsevier third-party host cloud base.
Exactly. As Haas mentioned, we have a website, and in that web page, all the data sets, there are probably more than 15 or 16 different examples that we have. So all of those data sets and the Jupyter codes are there, so easily can be accessed by the readers or audience.
Great. So Haas briefly mentioned about the math and theory. Does it really, how much deep is it go into these concepts?
Yeah, I think it's a good balance. That's a great question, right? So we just didn't want to, write, because like to be honest with you, you can write a whole book, just on the theory of neural networks and like in deep learning. There's just so much that you can cover, right? But we wanted to focus on, just give clear guidance on what each algorithm is, or what are the most common algorithms are, like for example, what is, we dedicated one chapter to, supervised learning. We dedicated one chapter to unsupervised learning. We have one chapter for neural network and deep learning. We wanted to focus on each algorithm, and go over the mathematics behind each one. And maybe we can even like solve it by hand, like for example, principal component analysis. You hear this all the time, well, here's how you calculate your eigenvalues, eigenvectors, and so on and so forth, step by step with hand before even going into Python, So we've illustrated that, and then once you understand the math, then we go into the actual, this is how you apply it in Python. This is the scikit-learn library that we use, for example, and this is how you import your data set. This is the example that we're going to do, and here's the step-by-step guide to walk you through the example. So I think it's a pretty good balance. Like the entire book is 480 pages. Let's say 500 pages. So we have pretty good detail. We've provided pretty good details on each algorithm, and also have a like step-by-step example that you can follow, So I think it's a pretty good balance in my opinion. But again, I think the readers should be the judge, on how good of a balance it is. And we appreciate feedback. So if you read the book, and honestly, the first 2 chapters are actually online. If you just type in the book, the first two chapters can be accessed like for free. You know, we want to hear your feedback. You know, this is something that we did just because we both have a lot of, you know, at least I can't speak for Dr. Hayat, but you know, I have a lot of passion for writing, and that's what I do in my hobby time, you know. So we appreciate your feedback, and as far as if we can improve on things that we didn't do in this edition, we would love to incorporate those changes into future editions.
Yeah. Oh, yeah, great. I mean, you both has an engineering background, so I'm guessing the book is pretty straightforward with someone, let's say, with the geology background or the business background. I mean, so the math is not hard. Don't be afraid.
Yeah.
But why did you guys choose Python? I know Python is like probably one of the most used programming language, but is there any specific reason that you chose Python?
Yeah, so you know, this was I think we chose Python because, you know, so you can do machine learning in, you know, in MATLAB and R and Python, and you know, you can use any programming language to do machine learning, right? To deploy these codes, you know. But you know, like in today's day and age, like I believe like Python was the most popular, at least language, you know, in terms of there's a strong support, there's a strong community behind it. You know, let's just say you type in like 5 lines of code in Python and you get an error message. You can literally take that error message and paste it into Google, and it will tell you, like, a lot of people before you have asked the same question, you know. So there's a strong community behind it that uses Python, right? That's one reason why we decided to go with Python. And also, two, Python makes it very easy in terms of applying machine learning. Like, for example, you know, when you read chapter 1, you know, we talked about how you can download Anaconda distribution, which has a lot of these libraries within Python already installed. So you don't have to go on your prompt and do pip install this library, pip install that library. You can actually download Anaconda, and most of the libraries that we use in this book have already been pre-installed on Anaconda. You know, so with Python, a lot of these libraries are already there. You know, you're just importing once the Anaconda distribution is downloaded, you just import these libraries, and you're gonna see how easy it is to actually deploy these algorithms. You know, that like so what Python has done is pretty powerful. They've taken all these tens or hundreds of lines of code and summarize it into a library. Like, for example, you know, the scikit-learn the scikit-learn library is a library that has a lot of these different machine learning algorithms within it. You know, TensorFlow has deep learning. You know, you Seaborn and the Matplotlib and Plotly. These are powerful visualization libraries. You know, Dash is used for creating dashboards. You know, these are very powerful libraries that are already there, and you don't have to reinvent the wheel. You know, you can pretty much use these libraries, import them in, and start using them like immediately. And also, it's free, it's open source. You know, you don't have to pay a different company or a commercial software package to get these libraries. It's all free, it's open source. You can literally go online like right now and type in Anaconda distribution, download the whole thing, and the rest is just learning it, right? So it's free, it's open source. I guess I might be a little biased about it, but it is easy to use. You know, once you learn the fundamentals, you can really do a lot of things with it. And there's a huge community, huge support behind it, which is really very, very important. You know, so that's pretty much why we chose Python. But as I said, this is not to discredit other languages. I'm sure we have a lot of R enthusiasts. We have a lot of, you know, MATLAB enthusiasts. This is just, we thought this would be a book that the language would be free, open source. It'd be easy to follow. and it'd be a good resource for everybody to use.
No, there is no doubt that the Python is a great coding language, and yeah, well, that's great. I would like to ask about the structure of the book, the chapters. Like, if Alireza maybe can go through the chapters just very briefly, just tell us, okay, what each chapter is about, and then at the end, if he can talk about the neural network, why he has a dedicated chapter for the neural network. I mean, it's already been explained a little bit in chapter 5, but there's a separate chapter on that. So that would, if Ariza you can do that, that would be great.
Sure. I'll briefly talk about, the chapters and, what each chapter talks about. The first chapter is about, if I'm right, introduction to machine learning and Python. So we briefly talk about, different machine learning workflow, what is artificial intelligence, what is machine learning, and, Python, how you can install Python on Anaconda, and how you can, run the Python code. And then in the second chapter, what we really want you to learn is about, how you can import the data and how you can perform some visualization. So how you can handle the data, bring the data into the Python, and then when you have the data, how you can make some visualization, different charts, different graphs, so we show you how you can build those graphs. And in chapter 3, we mainly talk about overall machine learning workflow, from A to Z. What are the steps that are required to perform some machine learning job? We explain about all the steps, all the processes that are required to go through a full loop of machine learning. And then we break it down. Each machine learning technique or machine learning algorithm that we are going to use will be covered, in next 2 or 3 chapters. So we start from unsupervised machine learning and, clustering algorithms. When we don't have labeled data, in order to find some patterns in the data and classify the data, we need to perform some unsupervised machine learning techniques. So in this chapter, we mainly go through these unsupervised, techniques. And then when we cover all of these, most of this algorithm, we go to chapter 5, which talks about, supervised learning. When we have the labeled data, when we have output and input, and we can find a correlation between those outputs and inputs, what we need to do, we need to perform some supervised learning. And in that supervised learning chapter, we bring a lot of examples, and I believe we have more than 10 different machine learning algorithms for supervised learning in chapter 5, with examples and all the steps and workflows. And as Haas mentioned, a good balance between theory and application. And then when we discuss about all of this supervised learning, we go to chapter 6, which is again a supervised learning technique, and it's called neural network. So we dedicate one full chapter for neural network because of, I think, two main reasons. So what we really want to get from machine learning, machine learning, what it does, it tries to learn some pattern within the data with some sort of, learning algorithm. So one of the most important learning algorithm is actually come from how our brain, learn something. So this process of learning in our brain with our neural networks, can be easily applied to machine learning problems. And neural network has been one of the most widely used machine learning technique, since it was invented. So it's very practical, very, very, widely used. So that's why we try to dedicate one chapter to just neural network. When you search about machine learning, one of the most, important algorithm that comes up is neural network. So we really wanted to show how neural network, works. Some people say neural network is a black box. We really don't want you to deal with black box. We wanted to uncover this black box. And in this chapter 6, we went a little bit more into depth of the theory of what neural network is, so the reader can understand what's going on. behind the neural network and apply the neural network for some of the problems. The other reason that we really dedicated one chapter to neural network is nowadays, two things are happening. The first thing is the existence of data. So gigabytes or terabytes of data are becoming available. In other industries, it happened probably 10 years ago, but nowadays in oil and gas industry, we do see, a lot of data like, sensors, gauges, seismic data, microseismic data. These huge data sets are available. This is called big data. So we have the opportunity to learn from these extensive resource of data. The other thing is computational power has been improved significantly. GPUs, supercomputers, parallel computing, cloud computing, they help us to perform some of these processes very fast and easily. So what happens is these computations, these algorithms are becoming more complicated. They can process more data faster. So how we can perform these tasks to learn from this big data is some subject which is called deep learning. And it's an important topic that is gaining a lot of popularity nowadays. We wanted to touch on deep learning, but the main building block of deep learning is neural network. So that's why we really wanted to go deep into neural networks, since we want to touch on deep learning. And then this is the chapter 6. In chapter 7, when you are able to build a machine learning model, you need to evaluate that model. So chapter 7 talks about model evaluation. Is the model good? Is the model poor? How we can improve the performance of a model with model evaluation. And then in chapter 8, we will talk about fuzzy logic. And finally, in the chapter 9, we will finish this book with evolutionary optimization, which consists of genetic algorithm and particle swarm algorithm.
Great. You mentioned some examples and data sets. So is there any actual or real oil and gas data set in the book?
So I talk a little bit, and Haas, feel free to jump in if you want to complete. So, for this book, we tried to provide wide variety of examples for different disciplines. Example for geologists, for drilling engineers, production engineers, completion engineers, reservoir engineers. So there are examples for each discipline. And some of these examples are based on actual data. So for example, for a geologist, we have a facies classification example that is based on, different well logs in Kansas state. So this is the actual oil and gas example. And for sand production for a well, we have a data set that I think it has more than 40 wells that actually experience sand production. So this is an actual database. And I know Haas can come up with some actual data sets that he used, for some of the problems in this book.
Yeah. So to answer your question, some of the examples are used from publicly available data sets. The state data set. You have MSEAL, data set that has like a lot of data from the Marcellus Shale available. The Volvo data set also that has a lot of examples in there. But so some of the examples are from actual data sets, and some of the examples are actually synthetic, but they're all related to oil and gas, and it gives a good flavor to the reader as far as what problems can be solved within the oil and gas industry.
Oh, awesome. Great.
I wanted to touch on one thing. So I think chapter 9 is probably one of the, even though it's the last chapter of this book, it's probably one of the most important chapters that I want to emphasize on, because it really brings the entire book together. We've gone through all these algorithms, all these things. Now, what is the final piece, which is optimization? How do I optimize drilling? How do I optimize, production? How do I optimize completions? And it talks, as Dr. Haggad mentioned, it goes through two main algorithms, the genetic and particle swarm, and how you can deploy these algorithms in Python. And it's very powerful. I've personally used those algorithms many times myself. you know, to solve different problems. And it's pretty fascinating how great the results have turned out to be. You know, so if you read the book, don't read the first 2 chapters and then stop. Finish until the last chapter, and I promise you, you're not gonna regret it, at least, you know. So.
Yeah, I mean, I personally myself went through the first 2 chapters and they've been great. I mean, especially the second chapter, it was really good. I like it, you know, the whole visualization part, because I'm in my day-to-day jobs, I'm involved with lots of, you know, PowerPoint, and then show that, okay, what's the meaning of this events, and then visualizing those is important. I mean, I really like the second chapter. So is the book enough for an engineer or geologist to learn machine learning for oil and gas applications?
So I can comment on this. So I believe this book is a very good start for a professional in oil and gas industry to learn machine learning and apply machine learning for a daily workflow. So you can go through most of the steps that are required to perform machine learning. You can start from, you know, their data import, data pre-processing. If there is an outlier in your data, you can remove that. If you have missing data, we teach you how you can handle missing data. If you have, you know, some data that are not integer, we show you how you can digitize, you know, some of the data. So data pre-processing is covered. And then if you want to apply it, you know, a machine learning algorithm and find some trends in the data, we again show you some other data pre-processing, like, you know, normalizing the data, standardizing the data. And then when the data is ready, you can build a machine learning model, you can evaluate the model, you can see the results, and then apply that model in order to predict something. And as Haas mentioned, at the end of the book, we close the loop. When you have the model, you can perform some optimization, maximize something, minimize something. So the book is enough resource to learn machine learning and apply machine learning. You know, in my day-to-day job, I talk to a lot of engineers. And when we say machine learning, there is a fear. You know, this word, they don't like to touch on this word, you know, because they are afraid of machine learning. But when you read this book, you feel very comfortable to apply machine learning into your day-to-day workflow. So yes, it is enough resource to start making your hand dirty with machine learning workflows, and you will learn how to apply that. But however, like any other discipline, you know, if you want to be a real data scientist, if you want to get master in this topic, we highly recommend you to go and read other great resources that are in the market to improve your knowledge and improve your expertise. But the answer is yes, it's enough, but we highly recommend to bring in more books that are in the market.
Yeah, I mean, I personally find myself the book a really great introduction to the whole machine learning and data scientist. I mean, don't be afraid. Just, you know, it's a really great book. By the way, if you have any questions, feel free to post them on the chat section, and then we'll start asking questions from our audience in a couple of minutes. But if you guys want to go ahead and send your questions, please feel free to do that. So you mentioned about the examples, all the data sets that you have in there, but do you know any public data sets that could be used to practice? For example, I know myself, I work with Reading Info or Enverus on a daily basis, and then they have a huge data set. So besides that, do you have any recommendation for the public data set to just practice and try, you know, to learn beyond what the book has?
Yeah, I can take that question. So yeah, as I said, there's MSEAL data set. If you guys just type in Google MSEAL, this was a project that was between, I think, West Virginia University and Department of Energy and also another company called I believe Northeast Natural Resources. So they have published all the results from some of these Marcellus wells that they've done. It has a lot of good full data sets publicly available. you can use that one. And also the other one that I know of is the Volvo data sets that has a lot of data as well, drilling to geology to production information. And finally, you know, as I said, we have a link that has all the data sets that we use in this book that you can also use to kind of get started, you know. And I think as we're, you know, as the industry moves towards the future, you know, more and more data sets will become publicly available. You know, a lot more companies will publish some of the results that are not as confidential as they used to be, you know, like over time, you know, so that's also a possibility.
Oh, great. And I think I is touch this question a little bit, but so how can someone apply the methods from the book in its day-to-day job, like as a petroleum engineer or as a reservoir engineer?
Yeah, so I can touch on that too. So you know, what we try to do in this book is show you the fundamentals and show you the steps, like the workflow. And I think once you read through each chapter, you're going to realize, oh, I could also apply this to this. Even though we've shown you an example on completions optimization, you can also think, okay, I have also, I'm in the development team right now, and I can also apply this to this, you know? So there's really no limits on what you can apply this to. Once you learn the workflows, then it all comes down to you as far as what other examples, besides the examples that we've shown you, which I think we have 15 plus examples in this book, what other examples you can apply this to day to day. So I think it's just a matter of, you know, going through each chapter and understanding the fundamentals and the workflow. And once you understand the workflow and the fundamentals, then you can think of some other ideas. Oh, I can also do this. I can also do that, you know, which is applicable to your day-to-day job, you know, depending on, you know, what you do like day-to-day. If you're a reservoir engineer, if you're a drilling engineer, if you're a completions or production engineer, you know, although we have some, you know, standard like examples in there that you can follow, but you can also think of other examples based on your day-to-day job responsibilities.
Okay. Well, awesome. You mentioned about the workflow. So these workflow, are these the ones that you use in your jobs, and then you found it, okay, this is an interesting workflow, and then I want to put it in my book? Or is it some like basic or like popular workflow between, you know, all the fields? I mean, not just the petroleum or oil and gas. Just would you talk about a little bit about these workflows?
Yeah, these workflows are not like, you know, just like our personal opinions on as far as here's how you do it. These are, you know, standard workflows that, you know, any data scientist would use, you know. We just touch on each one step by step. Here's how you do it. And here's why you do it. Here's like the reason why you should do it. You know, we provide explanation and also provide the reasoning behind it. Also provide references. You know, so that way it's not somebody's personal opinion or just my workflow. Is actually, these are just like standard workflows that are standard across different amongst different data scientists. You know, and also this is why we have to follow this workflow, and the reasoning behind it. So that way it's a pretty like a clear path, you know.
Oh, great. I mean, well, that's so great. Before I go to the our audience questions, do any of you gentlemen want to add anything to our panel before we open the questions?
I'm good.
All right.
Good.
So feel free to send your questions. You mentioned about the public data sets. Would you, one of our audience ask about those names? If you don't mind, just mention them again. That would be fantastic.
Yeah, I can type in the chat box MSEAL, and the other one is the Volvo data set. So I just typed in the chat box for everybody's reference.
Oh, great. That one of our audience asked about, does the book teach you a step-by-step processing and how to code and using Python?
Yes, that's exactly what it does. Yep, that's exactly the whole book. It goes through step by step. As I said, you don't have to have any background, any knowledge. You can follow the step by step workflow, and it's honestly like you can literally just go line by line of code, and we explain what each line does and what each function or indexing each line means. So it should be pretty honestly easy to follow. But again, I still let this book to be judged by the reader, not by myself.
That's true. Well, I would like to emphasize on the step-by-step part. So it's going to help all of you that are interested in the book that it's not that complicated. Don't be afraid of the word machine learning. So great. Well, I guess I covered most of my questions. And okay, you asked about any discounts for students?
Okay, so right now I don't think we offer any discount for students, but for sure we can communicate this request with the publisher and say if there might be any possibility to get discount for students. So right now there is no, but we will for sure communicate it with the publisher.
Okay. And many of these websites, if you are a student and you have like edu account and email address, would give you some discounts on this, especially Elsevier as like one of the biggest resources for the books.
Sure. That's a very good point. We will communicate it with the publisher.
Yeah.
Sure.
And also, if you're a student, if you go to your library, you can request the book and they'll get it for you. So part of your tuition goes towards library, and you can request it and they'll get it for you. So that's just one way of getting the book for free, or not for free. You're still paying through your tuition, but that's just one way of getting it,
Great. So if anybody has any question about the books or part of it, what's the best way to get in touch with you, two gentlemen?
LinkedIn. Yeah. Just send us a message on LinkedIn and give us a few days and we'll get back to you.
Awesome. Well, great. Habib, I have no more questions, and if you have any questions, please feel free.
No, thank you so much. Once again, I would like to thank Mohammad Dr. Khoshghadam and also Dr. Haqiqat and Mr. Belyadi for giving us this opportunity to have you here. And I'm very, very thank you that accepted our invitation. And just all the audience that were here, just for your information, a recorded version of this panel discussion will be available very soon in the social media of the APPIH. Thank you so much.
Well,
Thank you so much.
Thanks, everybody. So machine learning guide for oil and gas using Python, a step-by-step breakdown with data, algorithm, codes, and application by two great data science minds in oil and gas, Alireza Haqiqat and Belyadi. Thanks, everybody, for being with us. I hope you enjoyed this program. Thanks, everyone. Bye.
So much. Thank you.
Thank you. Bye.
Thank you. Bye.